And so now to take this a step further, whenever we have a rational expression, we want to identify the restrictions first, but then we actually want to simplify the fraction. Okay? So here's what we're going to do. Simplifying rational expressions, I have to identify the domain restrictions, so we figure out what x can't be, and I always want to do that first. Then I'm going to factor each piece completely, so I'm going to factor everything completely. Numerator, denominator, everything gets factored. And then I look for common factors in the numerator and denominator to cancel out. Okay? And essentially that's how I always have reduced fractions, whether I've realized it or not. You know, if a numerator and denominator are each divisible by 2, I'm canceling out that factor of 2 when I divide each. Okay? So I'm essentially going to reduce these fractions through factoring and canceling out common factors. All right? If I look at the first one again, I'm going to find the domain restrictions first. So what x cannot be. So this denominator cannot equal 0. I solve it by factoring. I factor out an x. And then I say each of these cannot equal 0. So x cannot equal 0. The x plus 4 cannot equal 0. And then I solve. The first one's already solved. The second one, I find out that x cannot equal a negative 4. And I'm just going to hold on to that information for a moment. Now I'm going to factor everything completely. Right here, the numerator I can't factor any further. It's already factored as a 5 times an x. The denominator I already factored it once. Don't do that work over again. I can just steal my work from this step right here. That was an x times an x plus 4. And now I look, I see an x in the numerator and an x in the denominator that are each factors. They're each being multiplied. So I can cancel out those x's, which leaves me with a 5 over x plus 4 for my simplified version. But then I also have to say, well, the simplified version is the 5 over x plus 4. However, x cannot equal the negative 4 and the 0. And I have to keep each of those domain restrictions, and I have to couple it with that answer, or else it's not the same as the original problem. Okay? It's the same thing with the next one. If I take the next one here, I'm going to find the domain restrictions first. So I set the denominator equal to 0. I say that this cannot equal 0. And then I factor this thing. I can solve by factoring. This is going to factor into an x plus 4 and an x minus 2. And then we set each factor equal to 0. So x plus 4 cannot equal 0. The x minus 2 cannot equal 0. And I solve each. Here I subtract the 4 from each side. Here I'm going to add the 2. So I'm going to get these two domain restrictions, that x cannot equal a negative 4 and x cannot equal a positive 2. And now I want to simplify this thing completely. I factor everything as far as I can. The x squared minus 4 is the difference of squares. That's x plus 2 and x minus 2. The denominator I already factored it once. Don't do that work over again. Factored into an x plus 4 and an x minus 2. I just stole it from my previous work. And now I have a common factor of x minus 2 that I can cancel out. Okay, so I look for those common factors, I cancel them out, which means my reduced fraction is the x plus 2 over the x plus 4. However, I need these restrictions that x cannot equal a negative 4 or a positive 2. Okay, so I have that reduced fraction, but that reduced fraction doesn't mean anything unless I include those restrictions. Okay? Same thing with the next one. Again, I start with that denominator. The 2x squared plus 5x plus 3 cannot equal 0. Once again, build a bridge. You come up with the 6. The two numbers are the 2 and the 3. Multiply to 6, but add to a 5. This one you can't use your shortcut on. You're going to have to split up the middle term and factor by grouping. And I'll tell you, when you do that, you should get an x plus 1 and a 2x plus 3. And then we set each factor not equal to 0. And we solve each. This one we subtract the 1 from each side. This one we subtract the 3 from each side. And then divide by the 2. So we find out that x cannot equal a negative 3/2 or that negative 1. Now we want to factor everything completely. And again, reuse some of that work you've already done. The numerator I can factor a 2 out of. So that's going to leave me with a 2x plus 3. The denominator I already factored once. It factored into an x plus 1 and a 2x plus 3. And now I have the 2x plus 3 in common. I can cancel those out. So my reduced fraction is the 2 over x plus 1. But I need those restrictions of x, that x cannot equal the negative 3/2 or the negative 1. Okay, so my reduced fraction has to be accompanied by those restrictions that I found. Okay? Same thing with the next one. I start with this, this denominator, the x squared plus x minus 12 cannot equal 0. I solve it by factoring. This is going to factor into an x plus 4 and an x minus 3. And I set each factor not equal to 0. And I solve each. Over here I'm subtracting the 4. Over here I'm adding the 3. And so once we get in the habit and routine of these, it's really just a matter of using things we already know how to use to find these restrictions. Okay? So I've got my two restrictions. Now I want to reduce the fraction completely. The numerator, that can factor into an x plus 3 and an x minus 3 because that's a difference of squares. The denominator we already factored once. It was the x plus 4 and the x minus 3. And now I have that common factor of x minus 3 that cancels out. So my reduced fraction is the x plus 3 over the x plus 4 with the restrictions that x cannot equal a negative 4 or a positive 3. Okay? So again, we need those restrictions to accompany our simplified version. The last two here, if I look at the first one, again, I'm setting this thing equal to 0 or not equal to 0. I may notice that common factor of 4 that I can divide out, which leaves me with a 3x squared plus 2x. And now I can solve this by factoring. I factor the x out, leaves me with a 3x plus 2. I say that each of these factors cannot equal 0. The first one's already solved. The next one I have to subtract the 2 from each side. And then divide by the 3. So I've got my two restrictions here. Now I want to simplify this thing completely. Again, that numerator is already factored. It's just the 4x. The denominator, I can factor out the 4x, which leaves me with a 3x plus 2. And notice I factored a little differently this time. Instead of dividing by the 4, I had to factor out the 4 and the x, so the number on the outside changes a little bit. But now I can cancel out those 4x's. And keep in mind, this is division. When I cancel things out through division, it leaves me with a 1 in my numerator. Okay, not a 0, a 1, because I canceled through division. And then I have to include those restrictions that x cannot equal the negative 2/3 and the 0. Taking a look at this last one. Again, we start with this denominator. I can't have a 0 in my denominator, so I set the denominator equal to 0 or not equal to. And here I build a bridge. It gives me a 12. The two numbers that multiply to 12 that add to the negative 7 are going to be a negative 4 and a negative 3. You're going to have to split up that middle term and factor by grouping. I'm just going to write it as the 3x minus 4 when you factor this thing, and you'll get an x minus 1 as well. Okay? And now we set each factor equal to 0. And I solve. I'm going through this same process. Okay, so I've got my two restrictions. Now I want to simplify this fraction completely. In that numerator, I can factor out a 2 to start. So that's going to leave me with an x squared minus 10x minus 21, plus 21. The denominator I already factored once. Don't do all that work again. Just rewrite the factors you already came up with. The numerator I can factor further. That trinomial in parentheses is going to factor into an x minus 7 and an x minus 3. And so as I look at this thing, I'm looking around trying to figure out how this thing is going to reduce, how it's going to factor, how I'm going to cancel out common factors. And really, there's nothing here. Nothing cancels out, so there's nothing I can do to reduce this. I'm going to leave it the way it is. And then I'm going to say, with these restrictions, x cannot equal the 4/3 or the positive 1. And you can leave it in the factored form like this, and that is fine. Or you can leave it as the original because nothing reduced or canceled out anyway. Okay? So again, list your restrictions, what x can't be based on the denominator, then factor everything completely, and then cancel out any common factors.